Learn, right? Okay, so today, 220. Right? Here's what we're going to do. Domain, range, and functions introduction. Oh, I should write bigger? Oh, I can write bigger.
No, it's okay.
Yeah? Okay.
I can see.
All right.
For my notes, I'm gonna write down with big letters.
I understand now. So here's what domain is, right? Let me tell you what all these things are first. So when we're talking about domain, it's the set, which is like the group, right? Or collection. It's the group of all inputs, which is X. X is the input. So if they ask you for the domain, what they're asking you is, this seems like a weird question, they're asking you, what number can you use? So like, let's say we had an equation, like, I don't know, 1 divided by X. So the way these work is X is the input, and Y is the output. So it means you plug in a number, you do some math, and you get an answer. The answer is the output, that's the Y. Right? So like, for example, ones we've been doing, linear equations like this, right? Y equals X plus 1. So like if you put in a 3 for X, you get out 4 for Y, right? So this is your input, that's your output. Now the domain is not 3, because the domain is all of the inputs. 3 is just one of them. Okay, so we get so far, right? Maybe not with what domain is, but why 3 is not the domain. It's in the domain. It's like saying, Ernesto's a human, right? That doesn't mean that every human is Ernesto.
No.
Right. 3 is in the domain, but there's a lot more. It's just
More
part.
possible answer.
There's more numbers you could use.
There's more numbers.
Now this one right here, you know how you can't divide by 0? You can't divide by 0, you get undefined, right? This means for this equation right here, that means X can't be 0. Because 1 divided by 0 is not a number. So for this one, here's what I'm hoping you see. You can use any other number. You can use 1 or 4 or negative 0.3. You can use anything else, but you cannot use 0. Because you can divide by all other numbers. You can divide 1 by anything except for 0. So that's why for this one, the domain, we're just going to say for right now, everything but 0. So not 0. Because the domain says what number can you use for X. And it's really confusing when you're learning at this level because it's hard to imagine not being able to use a number for an equation. But you understand you can't plug in a 0 here because you can't divide by 0, right? And in fact, on a graph, there would be like a weird thing that happens where 0 exists because it's not part of your answers. You can't put a 0 in. Like there's no way, like if you put 0 for X, you're not going to get any number out for Y. You don't get anything. But if you put in 1 for X, then you get 1 divided by 1, and your output would be 1, right?
Y would equal 1.
Right. But if you put a 0 for X, what's Y equal? Nothing. 0 doesn't lead to anything. You put a 0 in, you don't get anything back because you can't divide by it.
So we're solving for Y?
Well, no, we're just trying to figure out for domain. We're just being asked what are the inputs? What numbers could you use for x? Now, the way that I think what you're asking about is we were talking about the relationship, like the input to the output.
Okay.
So that means you put a number in for x and then you solve for y. Yeah, you figure out.
Okay.
Yeah. Okay, now the range. It's all of the outputs, which is y. Okay. You know, the word function, it means like something's purpose, like what it does. Right? Something's function, like the function of your watch is to tell time. Right? In math, we say that y is a function of x. There's an ugly definition for what functions are. We're going to get to that later. Right now I want to get more of a natural sense, and then we'll introduce like more specifically. So like this thing right here in math, we don't actually write that out. Here's what we write instead.
Oh man.
I know.
I've never seen
That just means y is equal to this. It just means that y is a function of x. All that means is that whatever value y has, it's depending on what x is.
that. That's why there's a function type in the calculator.
Yep. Yep. It's just a function's okay. A function, for what you guys have seen so far, a function is basically just an equation. There are some equations that aren't functions because there's some tricky rules about functions, but basically, for right now, for what we know, a function is just an equation with an input and an output, with an x and a y. And we say the y is the output.
Input being the number you got to figure out, and the output being the number that's gonna come out from the.
Yeah, input's the number you plug in, right? And output's what you get.
Is what you get out from what you plug
Right,
in.
right. Yeah. All right, so, let's see here. Let's do this right here. Oh, man. Check this out. That means y. It's the same thing as y. And we the way we say it out loud is we say f of x. That's how we say that. And it just means y is a function of x. Valentine's Day passed, but you know. Yeah. Y is a function of x. All that means, Ernesto, is it means that the value y has depends on what x was. The way we get y is by doing something to x. So let's say we had this equation right here. Oh, the square root of x. Your favorite, right, Celine? Square roots? Oh man, this is fun. Okay, so check this out. I'm going to graph it for you. Here's what the graph looks like. It starts here at 0, 0. And then it goes to 1, 1. Because the square root of 1 is 1. Yeah? So in fact, if we were going to do a t-chart, like check this out. Oh, this is fancy. This is extra. This actually isn't in the book at all. I'm hooking you up. Watch. So 0. So then what you do, here's how you do this. This is how they write it. The f of 0 equals 0. Now what this means, this is saying, oh man, I got to write this over here. F of 0 says, what is y when x is 0? That's what that means. And so it says it's equal to this, and so we just have to simplify this. And that's 0, right? So here's what we got. 0, 0. X is 0. Plug in x, simplify it, and figure out what does y equal. This basically says, like the nice thing about this is saying, it's kind of like saying, hey, This is what y is equal to when x is 0. Because this is showing you, this number inside the parentheses is showing you what x is. And so, like, for example, let's skip ahead to 4. What this means take your function, and everywhere you see an x, you put a 4. So what we're going to do is we're going to do the square root of, there's 4. The square root of 4 is 2. So x is 2. Sorry, x is 4, y is 2.
Y is
2. Because this whole thing says, what this says, what's y when x equals 4? That's what this part right here says. That's what it means. It's tricky, right?
Yeah.
It's a way of writing some instructions without writing out the words. But that's what that means. Yeah, so this says, if x is 4, this says if x is 4, what is y? And it's 2. 1, 2, 3, 4. So x is 4 and y is 2. You see? Okay, one more. I want you to figure out this one. What's that equal? Oh! I gave you the answer. F of 9. Do you know what to do, Ernesto?
What? Yeah.
You see our function right here?
Yeah, you draw out the.
Put the 9 right there.
Yeah.
And then do the math.
You just solve for the reciprocal, I mean the square root of 9.
Right, which is
3.
3.
That's your answer.
So that means it's like an ordered pair. X is 9 and y is 3. So when x...
Give me like 1 point, you just got to figure out the other one.
Right. Exactly like that.
You're just figuring out the y-intercept.
Or, yeah, just the y coordinates. So
the y coordinate. Yeah.
Here's what the graph looks like. It's weird.
Curvy like that?
Yeah.
Wow.
Let me show you on decimals. Square root x. Oh, no. See?
Oh.
It's weird looking, right? Because we have 0, 0. Because the square root of 0 equals 0, right? We have 16, comma 4. Watch. Ay. 16, 4. Because the square root of 16 is 4. So it looks really funky like that. So check this out. You know, you can't take the square root of a negative number. Like there's no square root of, let's see here, negative 4. Because that says what number times itself equals negative 4. 2 times 2 is positive 4. Negative 2 times negative 2 is positive 4. You can't put a negative 4. That's why it's not over here. You see there's no value for x over here at negative 4. 1, 2, 3, 4. There's no y. If you put a negative 4 for x, you don't get an answer for y. And that's why your graph starts right here. Do you see how that's related to domain? Domain is all of the possible inputs. It's all of the possible x's. So for this one, the domain, yeah, we can see that, is x is greater than or equal to 0. You could write that out in words if you wanted. It's 0 and anything bigger. 0 to infinity, all kinds of ways you can say it. You look like you have a question, Ernesto.
No.
Just tired.
Yeah.
That Circle K coffee didn't work?
No, it did not.
Yeah, that's a bummer. All right. Let's see. What about the range? Range is all of the y's. All the outputs, all the y's. Do you see how there's nothing down here?
So it's going to go up.
So the range, the first thing in the y, the first y we have is right here. And then it goes up. Because like, it doesn't, this isn't the first one because it crosses here. It's the first one because looking up and down, this is the lowest point. So the range is from 0, and then it goes up. And it's going to keep going up forever. So it's from 0 to infinity also. I know that's new, that's kind of weird, it's really abstract. It's very strange. Okay.
And we're gonna graph them too?
No, I'm not going to ask you to graph this, it'll usually give you the graph.
Oh, okay.
But the reason I wanted to do the graph is because I wanted to teach you how this works right here.
Okay.
What that notation is. Okay? Okay, last thing for the day. This is fancy, Celine. You ready? Here's what a function is. It's not going to be the full definition yet either, okay? I want to break, it's a kind of a long definition. I want to break down parts. So we understand with a function you got an input and you have an output, right? And they're related. Okay? So each input has exactly one output. So that means each x has a y, but only one y, not two. So sometimes you see stuff like this. Here's our set of inputs, right? Here's our outputs. If this was a function, each of these numbers would go to only one of these. So each input has one output. So like, for example, should I give you a good example or something that's not an example?
I think a good example.
A good example first? Okay. Oh, I brought my pencil. Because we're going to erase it. Watch, check it out. This is good. This is going to be a function. That can go to that. That can go there. This can go here, and I don't know. Doesn't matter. It can go anywhere. That would be a function because you see each of these inputs goes only to one number. Now it's true these two go to the same number, but that's okay. So this is a function. It's not a graph, it's a table. Like these are the inputs, and there's some formula, I don't know what it is, and these are the outputs. And this is a function. Here's a not function. I'm not going to erase it. Here's a not function. 1, 3, negative 4, and 7. 2, 4, 7, negative 40, 1, and 3. So here's a not function. You ready? It's already a not function. It doesn't even matter what these others do. Here's why it's not a function. Each input has one output. See, this input has two outputs, not a function.
I didn't get it.
But do you see now?
Yeah.
Yeah? Okay. One more way. Check this out. This is with a table too. We're also going to do it with a graph. And there's a thing called a vertical line test. Celine in pink, do you want a function or a not function to be drawn? Okay, good. Here's a function. Ready? Listo? This is a function. And here's why I know. This is the inputs right here, right? So I have an input like right here, you see? That input has just one output right there. Here's another input right here, right? This input has only one output right here. Do you see? Ernesto, we good? There's every I could pick any spot I want on the x-axis, and that would give me a number that's an input. And if I look at that number right there, if I plug this in, remember a graph's a picture of all the answers. It goes to right here. That's the y. This number right here is the y. So that's the x and this is the y.
Yeah.
Every one of these x's, every one of these coordinates every one of these x's only has one y that goes with it.
Yeah, okay, so that's why you were saying they can't go to 2 points.
That's right. So this is a function. For sure.
Wherever you get a point, you go down, you're going to hit.
Yep, just one.
Just one number, yeah.
Just one number. Now you ready for a non-function?
Yeah, let me see it.
Okay, here's a non-function. I was going to do it on the same paper, but I'm going to do it here. Okay, check it out. Not a function. Here's a not function. This is not a function.
Because everything is on one side.
Yeah, well, check this out. Here's my favorite input right there. I just picked a random input.
Now you get one.
I get one here, and I get one there.
Uh-huh.
That's 2 outputs. Not a function.
So if we see a graph, okay, I see it now.
So the thing it's called the vertical line test.
That's why you do it right now.
So if you can do a vertical line and it touches your graph twice, anywhere, not a function. So an example that might be kind of weird looking would be something like, that's supposed to be straight up and down. This would be not a function. Because you see right here for x, I got a whole bunch of outputs.
But what if you go back to the other one up there, the one you're holding.
Oh.
Yeah. What about that line up in the y? You can't go to the
here?
right. Yeah.
Oh, see the arrow means it's going to head in the same direction, so it's getting wider and wider and wider. It's not going straight up. It's going up, but it's also going over at the same time. It's not going straight up and down.
No, yeah, it's going like.
Yeah. Yep.
Opening up.
That's right. What do you think, Celine?
Just learning.
Yeah. So practice is good.
Yeah.
Practice is good. So here's what we got. Here's what we got. So today's Tuesday. Tomorrow's Wednesday, right? And then Thursday.
Mm-hmm.
So I would really advise that you try, and it's just a few problems. I would really advise you try them tomorrow. Not today and not Thursday. Because otherwise, you skip that day, it's like starting that refrigerator again, right? It's hard.
Yeah.
Well, a little bit every day. I know it's hard to do, and some days it's tough. I get it. So here's what I would suggest. In your book, in chapter 2.1, that's page 160 and 161, I would say let's try let's try number 45. Okay, these ones right here are really, really easy. Through 52. They will take like 2 minutes to do. Because it gives you a graph, and all you got to do is say that's a function or not.
Okay.
Just by looking, that's it. Okay, and then this will take a little longer, so we'll just try a couple. 56 through and 57 and 58. For this one, they give you the equation and they ask you to plug in the numbers.
Okay.
So like they'll give you an equation like, I don't know, like here's one, x squared minus 3x. And what they're going to do is they're going to say, they're going to ask you to figure these three things out. So Celine,
Plug in the number in the F.
yeah, so like this one, you're going to go f of 0 equals 0 squared minus 3 times 0. Well, that's just 0, right? The whole thing. So that means your answer would be f of 0 equals 0. Whereas like this one, this will be our last one, okay? No, we'll do the negative. Negative's tricky. So this one, that would be negative 2 squared minus 3 times negative 2. So 4 plus 6 is 10. F of negative 2 equals 10. So that's what it's asking you to do there. Good? Good. So we got some practice. It's new. It's new. It's new. You have to use your notes. You might have to do. It's not too difficult. It is confusing because it's new, but it's not too bad. I think it's easier than a lot of what was on your quiz. Yeah, last week. Yeah, we're gonna be all right. So we there? We good?
Good.
All right. Fan freaking tastic.